Okay, if two functions are inverses, what I can say is that if I have one function f of x is x plus 2, and another function g of x is x minus 2, it is always true that if I plug g of x inside f of x, or vice versa, I should get x. In other words, if I take this x plus 2 and substitute it in where the x is, what I would end up with is a x minus 2 plus 2, which will simplify to just an x. If I did the same thing backwards, in other words, if I took f of x, the x plus 2, and stuck it in g of x, so I would have a x plus 2, and then the minus 2 is outside. I could cross that out and get just a plain x. That will be true for any functions that are inverses when I have their equation. Now, that's one way you can check the equation to see if it's an inverse when you get your answer, but you also need to be able to solve one. So the first thing you need to do to find an inverse is switch the x and y. So what I'm going to do is, instead of having a 2x plus 5, I'm going to have a 2y plus 5, and I'm going to say that's equal to x. And it might be helpful to remember that an f of x was a y to begin with, and when I switch it, I like to go ahead and change the y to an x and put it over there on that side. Now at this point, I'm going to solve for y, and my y is on the left-hand side if I do it this way. So I'm going to subtract 5 from both sides. So that gives me 2y is x minus 5. And then I'm going to divide by 2. So my answer is x minus 5 over 2. If you wanted to, you could check that answer by plugging 2x plus 5 in there. And if you did that, what you would have for your check is 2x plus 5 minus 5 divided by 2. Your plus and minus 5 cancels, then you'd have 2x over 2. The 2's cancel, and you would be left with a plain x. That lets you know you found the inverse correctly. But your final answer is going to be this here, with a y equals x minus 5 over 2, or sometimes instead of having a y equals, they'll write f inverse of x, or the f with a negative 1 of x equals the x minus 5 over 2. Go ahead and pause your video, get that written down, and then we'll go through a couple more examples together. Okay, on this next one, we need to start by switching x and y. So instead of x plus 3 over 4, I'm going to have y plus 3 over 4. And that's going to be equal to x. And remember, f of x is the same thing as y, so I change the y to an x and move it to the other side. Now, I don't like the fact that's a fraction, so the way to get rid of that divided by 4 is to multiply by 4. Before I can do anything with that numerator, I need to get rid of the fraction. So that gives me a y plus 3 equals 4x. Then I'm going to subtract 3 from both sides. And that's going to give me a 4x minus 3. And I can set that equal to my f inverse of x. Because y equals 4x minus 3, or the inverse of x, or f negative 1 of x, is 4x minus 3. We won't check that one, but if we did check it, it would work out correctly. On this one, it's got a little bit more going on with the square, but still, to find the inverse, I start by switching x and y. So instead of having an x plus 2 squared, I have a y plus 2 squared minus 1 equals x. Then I'm going to add 1 to both sides. So that's a y plus 2 squared is x plus 1. Now, I cannot do anything about that parenthesis until I get rid of the square. So remember, the inverse operation for a square is a square root. So I'll take the square root of both sides. The square and the square root cancel, so that'll be a y plus 2 is square root of x plus 1. Then for your last step, you need to minus 2. Remember, do not put that minus 2 inside the square root, so your answer will just be f negative 1 of x equals square root of x plus 1, and just leave the minus 2 outside the square root on the end.